Imagine a world shrouded in eternal twilight, where molten rivers carve through continents of fire, and the sky rains meteors like vengeful stars. A place so alien, so unforgiving, that life itself seems impossible. Yet, this was our Earth billions of years ago, long before the thunderous footsteps of dinosaurs echoed across the land. Welcome to a journey through time, where we'll peel back the layers of history to reveal the raw, untamed planet that birthed the Age of Giants. What secrets lie buried in the rocks? What forgotten dramas played out in the depths? Buckle up, because we're diving into the abyss of Earth's prehistoric dawn. Let's rewind the clock to about 4.6 billion years ago, when our solar system was a swirling chaos of dust and gas. Picture this: a colossal cloud collapsing under its own gravity, birthing the sun at its heart. Around it, fragments collide and coalesce, forming protoplanets in a violent bolide. Earth emerges from this cosmic forge, a seething bowl of molten rock, bombarded relentlessly by asteroids and comets. The impacts are cataclysmic, each one unleashing energy equivalent to billions of nuclear bombs. The surface is a hellscape. Lava oceans boil under a toxic sky thick with volcanic gases, carbon dioxide, methane, and steam. No solid ground, no blue horizons, just endless fire and fury as the young planet fights to find its shape. But even in this inferno, change is brewing. As Earth cools, its iron core begins to solidify, generating a magnetic field that shields it from the sun's lethal radiation. Volcanic eruptions spew out water vapor, trapped within the rocks from those early collisions. Overunes. This vapor condenses, falling as relentless rain to form the first oceans. Imagine the steam rising from a cooling cauldron, coalescing into vast, primordial seas. These waters are not the serene blue we know today. They're acidic, laced with minerals, and teeming with dissolved gases. The atmosphere above is a choking brew, mostly carbon dioxide and nitrogen, with no oxygen to breathe. It's a greenhouse world, hot and humid, where lightning storms rage across the globe, igniting the spark of something extraordinary. And then, in the shallow pools and hydrothermal vents of these ancient oceans, life stirs. Not with a bang, but a whisper. Around 3.8 billion years ago, the first microbes appear simple, single-celled organisms that thrive in the extreme heat. These are the prokaryotes, bacteria and archaea, harnessing chemical energy from the Earth's vents. Picture them as invisible architects, building the foundation of all biology. They form mats on the seafloor, trapping sediments to create stromatolites, layered rock formations that still dot remote shores today. Silent witnesses to life's humble beginnings. These tiny pioneers don't need sunlight, they feast on sulfur and iron, exhaling gases that slowly alter the planet's chemistry. It's a slow dance, but one that will reshape everything. As hundreds of millions of years pass, these microbes evolve a revolutionary trick: photosynthesis. Cyanobacteria, those blue-green wonders, begin capturing sunlight to convert carbon dioxide and water into energy, releasing oxygen as a byproduct. At first, it's a trickle absorbed by the ocean's iron-rich waters, forming vast deposits of rust that band the rocks in red. But eventually, the oxygen builds up, seeping into the atmosphere. This great oxidation event, around 2.4 billion years ago, is a turning point, a planetary makeover. The sky starts to clear, the greenhouse weakens, and temperatures plummet. Earth enters a phase of dramatic swings, from hothouse to icehouse. The air becomes breathable, but at a cost many anaerobic microbes perish in this new oxygen-rich world. Life adapts or dies, setting the stage for complexity. Now, fast forward to one of Earth's most harrowing chapters, the Cryogenian period. About 720 million years ago, the planet slips into a deep freeze, becoming Snowball Earth. Imagine the entire globe encased in ice, from pole to equator frozen 2 miles thick. What triggered it? A perfect storm, continents drifting into positions that disrupt ocean currents, combined with falling carbon dioxide levels from weathering rocks. Glaciers advance relentlessly, reflecting sunlight back into space, amplifying the chill. Oceans solidify, cutting off the sun's warmth from the depths. Life clings on in pockets, perhaps under thin ice near volcanic hotspots or in briny refuges. But the toll is immense. Massive extinctions wipe out swaths of microbial diversity. For millions of years, Earth is a silent, white sphere hurtling through space, a world on the brink. Yet resilience prevails. Volcanic activity pumps greenhouse gases back into the atmosphere, slowly thawing the ice. As the snowball melts, around 635 million years ago, the planet awakens in a burst of renewal. Nutrients locked in the glaciers flood the oceans, sparking a boom in microbial life. This post-glacial world is fertile, teeming with possibility. Strange. Soft-bodied creatures emerge in the Ediacaran period, disc-like organisms and frond-shaped beings gliding across the seafloor. They're enigmas, these early multicellular life forms, perhaps the first experiments in animal life. No shells, no skeletons, just delicate impressions in the mud, hinting at a garden of oddities. The oceans pulse with new energy as evolution tests bizarre shapes and survival strategies. If you're enjoying this journey through time, make sure to subscribe and stay with us for more incredible stories from Earth's hidden past. There's so much more to uncover, and we'd love to have you along for the ride. As we approach the dawn of the Paleozoic era, around 541 million years ago, something explosive happens, the Cambrian explosion. In a geological blink, just 20 to 25 million years, the oceans erupt with diversity. Life goes from simple blobs to intricate marvels. Why now? Oxygen levels are higher, enabling larger bodies and more active lifestyles. Predation emerges as a driving force, sparking an arms race of evolution. Trilobites scuttle across the bottom, their segmented bodies armored with calcite shells, compound eyes scanning for threats. Anomalocaris, the apex predator of its time, swims with fin-like appendages, its circular mouth ready to crunch prey. Hallucigenia waddles on spiny legs, a creature so weird it defies easy description, like a walking cactus with tentacles. Picture these ancient seas vibrant, chaotic underwater realms where jellyfish-like cnidarians float alongside worm-like priapulids burrowing into the sediment. Opabinia, with its 5 eyes and grasping proboscis, hunts in the murk. Pacaya, a slender chordate, hints at the backbone that will one day support vertebrates. The Cambrian is a frenzy of innovation, bodies with heads, tails, limbs, and senses. Fossils from sites like the Burgess Shale capture this snapshot in exquisite detail, preserving soft tissues in a muddy avalanche. It's as if evolution hit fast forward, filling every niche with wonders. But survival is brutal. Extinctions punctuate the era, weeding out the unfit
Continue
as
the
the
journey.
supercontinent of Rodinia
Subscreen
breaks
for more
apart,
worlds beyond
reshaping
time.
oceans and climates. Through the Ordovician, about 485 million years ago, life diversifies further. Nautiloids, ancestors of squids with straight shells up to 10 feet long, dominate as predators. Corals build the first reefs, creating bustling ecosystems. Early fish appear jawless, armored swimmers like astraspes, patrolling the shallows. The seas are a riot of color and form brachiopods filtering water, crinoids waving feathery arms like underwater flowers. But catastrophe looms again. A massive ice age at the end of the Ordovician triggers the first of the Big Five extinctions, wiping out 85% of marine species. Glaciers lock up water, dropping sea levels and exposing shelves. Volcanic ash clouds the sky, cooling the planet. Survivors huddle in the depths, adapting to a harsher world. Recovery comes in the Silurian, around 443 million years ago. Plants venture onto land, simple mosses, and liverworts colonizing wet soils, their roots stabilizing the earth and accelerating weathering. In the oceans, jawed fish evolve, giving rise to predators with teeth and fins. Eurypterids, the sea scorpions, grow to monstrous sizes, some over 8 feet, stalking the shallows. The Devonian follows, dubbed the Age of Fishes, where lobe-finned species like Tiktaalik begin bridging water and land, their sturdy fins evolving into limbs. Forests sprout towering lycopods, and ferns create the first woodlands, pumping oxygen into the air and altering the carbon cycle. Insects buzz into existence. Arthropods conquer the skies. Yet another hammer blow falls: the late Devonian extinction, around 372 million years ago. Multiple pulses of anoxia suffocate the oceans, perhaps from algal blooms or asteroid impacts. Up to 75% of species vanish, clearing the board once more. Life rebounds in the Carboniferous, with amphibians lumbering onto swampy continents, and giant insects thriving in oxygen-rich air. Dragonflies with 2-foot wingspans soar through fern-filled jungles. But the stage is shifting. Continents collide to form Pangaea, drying interiors and setting up volatile climates. As we near the Permian, about 299 million years ago, reptiles emerge better adapted to land with waterproof eggs and scaly skin. Synapsids, our mammalian ancestors, roam alongside early archosaurs. The oceans host fusilids and ammonites, intricate shelled creatures. But the mother of all extinctions awaits: the Permian-Triassic event, 252 million years ago. Volcanic eruptions in Siberia spew lava across 1 million square miles, releasing greenhouse gases that spike temperatures and acidify oceans. Up to 96% of marine life and 70% on land perish. It's the great dying, a near reset for the biosphere. From these ashes, the Triassic dawns, fragile and recovering. Archosaurs diversify, pterosaurs take to the skies, and the first dinosaurs appear: small, bipedal hunters like Iraptor. The supercontinent begins to rift. Volcanoes rage, but life finds a way. The stage is set: a world scarred by fire, ice, and renewal, ready for the Mesozoic giants to claim their throne. And so, as we emerge from this epic saga of birth and rebirth, remember this: our Earth is a survivor, forged in chaos, sculpted by catastrophe, and alive with endless reinvention. What wonders might the next chapter hold? The past whispers: listen closely and let it ignite your imagination.